Hello students, welcome you all in Numerical Interpolation lectures. I am Professor Pooja Paratane from Modern College, Pune. We have seen all the basic preliminaries which are required for Newton's Gregory forward interpolation formula, especially the forward difference operator. Also, the construction of forward difference table in which all the orders means first order forward difference, then second order, third order, up to till it exists. Also, we have seen that the maximum order of the forward difference exist is equals to n, and n is the number of values given to x starting from 0. That is, actually there are n plus 1 values of x. That is, suppose n is equal to 5, then there exist 6 values starting from x0, x1, x2, x3, x4 and x5. Then the maximum order of forward difference exists is delta raised to 5. If we'll try to find delta raised to 6, then it is equals to 0, which is the fundamental theorem of this difference, forward difference, for which delta raised to n plus 1 y0 is equals to 0. So let us see the Newton-Gregory forward interpolation formula and the examples based on this formula. So this is the Newton's forward difference interpolation formula. What is it? Y equal to fx equal to y0 plus u into delta y0 plus u into u minus 1 upon 2 factorial delta square y0 plus u into u minus 1 into u minus 2 upon 3 factorial delta cube y0 plus dash dash, so on. So it contains n number of terms. Now what is u? U is x minus x0 upon h. As we have seen that x0 is the initial value in the table. H is the common difference between two values of x, as values of x are equidistant. And x is the value at which we want to find value of y. So here actually this is a formula for y equal to fx. So this is our x. So in the question this x is given that find value of y at x equal to so and so. So that x we have to consider to find value of u. Now here we use 2 factorial, 3 factorial and all this. So what are these? So these are the factorial notations. What is the definition of a factorial notation? So here you can see the factorial notation means in general n factorial we can obtain is as the product of first n numbers. I am saying first n numbers starting from 1, not 0. Means n factorial equal to 1 into 2 into 3 into 4 up to n. So in this way if we have n equals to 2, then what it will be? So here I have shown, then 2 factorial is product of first two numbers. So which are two numbers? 1 and 2. So it is 1 into 2, that is 2. Next 3 factorial. So it is product of first three numbers, first three natural numbers. So here it is 1 into 2 into 3 equal to 6. Similarly 4 factorial is 1 into 2 into 3 into 4. Whatever here value of n equal to 3, 4, 5 and so on, till that numbers we have to consider the product here. If it is 4, then consider product of first 4 numbers, whatever is the answer. Then 5, consider the product of first 5 numbers and etc. So in this formula we are using this notations u. So here already I have given value of u is x minus x0 upon h. Then 2 factorial, 3 factorial, 4 factorial, all these values we can calculate. And the values y0, delta y0, delta square y0, delta cube y0, you can pick from the forward difference table, as we know now how to construct the forward difference. I think you people have done the exercise which I had given you at the end of lecture 3. So now you know how to construct the forward difference table. So same here, that delta y0, delta square y0, delta cube y0 are forward differences and can be taken from the forward difference table. This Newton's forward difference interpolation formula is used to find value of y, which is fx for given x. So x is given, at which value we want to find using this formula. So here h is always fixed as it is a common difference. Now one more thing you observe in this formula, that how to remember this formula. No need to remember the full formula, only remember first 2 or 3 terms. You can write automatically the next term. So how we are doing it? Now firstly we are considering y. Then u into delta y0. Now this y, delta y0, delta square y0, delta cube y0, this will be in each term. If there are 5 difference, then it will next term. In the next term there will be delta raised to 4. Then in the next term there will be delta raised to 5 in this way. And if you observe here, we are considering the forward differences of y0 only. That is y0 here, delta y0, delta square y0, delta cube y0. We know now which are these values and from which we have to pick up these values. Okay. Now this is our first term, right? So in the first term, so actually here, as we are calculating it from 0, if we'll start calculating, counting these terms as from 0, then it will be easy for you. So this is my 0th term. So as this is my 0th term, power of u is, means the terms of u will be 0 here. Okay. Now here only y0. Now next term there is single term of u and delta y0. Blindly you can write down these terms y0, delta y0, delta square y0, delta cube y0 as it is, and then add these terms of u's. I am telling you the trick how to remember this formula. Then u into delta y0. So with only single term of u is there. Now in the next term, again delta square y0 will be there, as it is the next term of delta y0, next difference of y0. So here how to get it now? This is my second term. This is 0th term. This is first term. So only one term of u is there. Now there are 2 terms of u's are there. So this is my second term, 0, 1, 2. So it is u into u minus 1. So here, as it is a second term, it is 2 factorial here. And 2 minus 1 is 1, that is up to u minus 1 you have to consider. So obviously in the second term, the next term will be added here, u minus 2, as it is a third term. And instead of 2 factorial, there will be 3 factorial. What will be the next term? Then this next term will be, let us write down here, what will be the next term? Let us write it. Okay. So this is my third term. Now I want to write down the fourth term. So obviously delta raised to 4 y0 will be there. Okay. So this term will be, now I will give you here the next term. See, this is my next term. Look at here. So here it was u minus 1, u minus 2. So in the next term there will be u minus 1, u minus 2 and u minus 3. Extra one term is added. Now here there is 3 factorial. So in the next term there will be 4 factorial. You can see here this term 4 factorial. And here delta cube y0. So what will be my next difference? It is delta raised to 4 y0. Then if I want to write down the next term, then the next term will be delta raised to 5 y0 in this. And obviously there will be one term here we have to add, that is u minus 4, and here there is 5 factorial. Right. So let me show you what is that term. Yeah, here is the term, you can see this. Next term, u into u minus 1 into u minus 2 into u minus 3, and here as up to u minus 3, so next term will be added as u minus 4, right? And here 4 factorial, so here there will be 5 factorial. And the next difference, that is delta raised to 5 y0. So no need to remember this whole formula. Only remember first 2 or 3 terms. We can write down next terms automatically. And here we just write down the terms till our forward differences will exist. Suppose in the table only up to delta cube y0 will exist, and you write down up to 3 terms up to delta cube y0, and then next write down plus dash dash. Don't stop over there because it is infinite. Means here it contains n. So here the formula is up to delta cube y0. In that example, you can write it up to delta cube y0, but in general, when you write it, you write plus dash dash dash. If in the table there are only 4 differences, then write the term up to delta raised to 4 y0 and plus dash dash, and so on. So in this way, as per the forward difference table, how many differences will exist, according to that you can write down the Newton's forward difference formula. So it's very easy to remember. Only remember first 2 or 3 terms. Here first 3 terms is okay, because from this term u into u minus 1 upon 2 factorial into delta square y0, you can write immediately the next terms. Okay, let us go to the example. So now this formula is clear, I think. So this formula contains all the forward differences of the function y0, delta y0, delta square y0, delta cube y0, and the values of u, the terms of u. Here if you observe one thing in the formula, directly x is not there in anywhere. X is not there anywhere. X is where? Here in the value of u. So first of all, when you want to apply this formula, first of all we want to find value of u. Okay, so let us go to the example. This is the example. From the data, estimate the premiums for the policies maturing at the age of 46 years. So here are the values of x: 45, 50, 55, 60 and 65. Then premium y, it is 2.871, 2.404, 2.083, 1.862 and 1.712. So here first we have to construct the forward difference table. So I have already constructed the forward difference table here. Look at here. This x is 45, 50, 55, 60, 65. These are the values of y's. I have given only name to this first value y0 as 2.871. So obviously this is y0, y1, y2, y3, y4. According to that, now the differences. Now what is this first difference? It's delta y0. So what is delta y0? Delta y0 is 2. It is a little bit, yeah. So here it is 2.404 because y1 is 2.404 minus this 2.871, which is equal to minus 0.467. So in this way now I have obtained all the values of this forward differences. Now you know how to do it, so I will not explain it again. This is my delta y1, delta y2, delta y3, delta y0, delta square y0, delta cube y0 and delta raised to 4 y0. I am interested here only in the values of first the forward differences of y0, means this value, then delta square y0 because I need these values in the formula. Then next value is delta cube y0 and this last value. So I am interested only in this value because I have to substitute it in the formula. But to calculate these values carefully, I have to construct the whole, I have to find values of whole table and whole differences very carefully. If this any value is wrong, then your final value will be wrong. So let us go back to this formula now. Example. So here x0 is equal to 45. The first value of x is 45. So let us write all the values given. Then y0 equal to 2.871. Here is y0 2.871. And what at the age of, here what is x? X is 46 here. At the age of 46 here we want to find value of the function y. So here x equal to 46 and h is obviously 5. Now you know how to calculate h. It is difference between first two consecutive values of x or any two consecutive values of x, which is 5 here. So h equals to 5. Let us write down the formula. So this is the formula now. So I have 5 differences. How many differences will exist? 4 differences. So I have written only up to the 4 differences. Okay. Now let us pick up the values from the table. Now as we have constructed the forward difference table, these are the values from the table, where y0 is 2.871, delta y0 is minus 0.467. You can see here minus 0.461, delta square y0 is 0.146. Here it's 0.146. Then delta cube y0 is minus 0.046. Look at here, it is minus 0.046. Generally we say it is not 46. And delta raised to 4 y0 is 0.075. So let us write here not here. Delta raised to 4 y0 is 0.075. So all these values we have collected. Now here we want to find all the values related to u. So first we'll calculate value of u. What is the formula for u? U equal to x minus x0 upon h. So x is what? 46. Already we have written here value of x. X that is 46 here. X is 46 and x0 equal to 45. Okay. So here 46 minus 45 upon h is my 5. So it is 1 upon 5 and 1 upon 5 is 0.2. So this is only value of u. Now find values of u, values of related expressions of u separately, so that there will not be any mistake. So here u equal to 0.2. So first I will obtain all these values. So there are a number of ways. As you feel comfortable, you can calculate the value. So here I have calculated first u minus 1, u minus 2, u minus 3. So you calculate it here. So u minus 1 is minus 0.8, u minus 2 is minus 1.8 and u minus 3 is minus 2.8. As soon as you calculate this value, it is very easy to calculate the next value. So here this is my third term values of u. So here u into u minus 1 upon 2 factorial. We know 2 factorial is 2 and u is 0.2 and u minus 1 is minus 0.8. So finally the value is minus 0.08. Next value is u into u minus 1 into u minus 2 upon 3 factorial. So here u is 0.2, u minus 1 is minus 0.8 and u minus 2 is minus 1.8. And if you calculate it, here now multiplication, there are two negative numbers. So multiplication of this minus and this minus will be plus. So therefore whole product will be plus. So it is 0.288 upon 6, that is 0.048. Now next value, because we have 4 terms, means delta up to delta raised to 4, so up to 4 factorial terms. So again u is 0.2, u minus 1 minus 0.8, then u minus 2 is minus 1.8 and u minus 3 is minus 2.8. Now again here if you observe, 3 negative values are there. So as we know that product of negative with negative is plus. So this product will be plus. But this plus with this negative will be minus. So therefore finally our product is minus. So it is minus 0.8064 upon 24, because 4 factorial is 24. Product of first 4 numbers, 1 into 2 into 3 into 4. So it is 24. So answer is minus 0.0336. So you have to take care of the signs very carefully, so that answer should be correct. Now we substitute all these values in the formula. So here what was our formula? I will show it again here. So it is y0 plus delta y0 plus u into u minus 1 to delta. So however there are terms delta raised to 4 y0. So till that we will consider here. So first term is y0. Your value is this. Then next term is u delta y0. So there this is value of u and this is value of delta y0. You can check it here. Then this is u into u minus 1 upon 2 factorial. That's what you calculate this value separately, so that in the formula if we'll substitute according to this, then it will become very complicated. So find values of the terms in the formula separately and then assemble it and get the answer. So here minus 0.08 into delta square y0, that is 0.146. Then next term will be delta cube y0 and related term of u. So it is 0.048 into delta cube y0. And the last term will be delta raised to 4 y0 and along with the terms related to u. So it is minus 0.0336. Here you can see this value. This is 0. U into u minus 1 into u minus 2 into u minus 3 upon 4 factorial. Already we have calculated this value here, minus 0.0336 into this. Now what you have to do, you have to just calculate it properly, carefully, taking care of the sign and get the answer. So here it is 2.871 and the product is now here plus value and minus value. Here final value is minus. Again here one thing you should observe, that every value I have put it in the bracket. It is very essential to keep the meaning of the signs properly and get the answer correctly. So here this term is plus, this term is minus, so final answer is minus. So it is minus 0.0934 product of this. Again here one term is negative, next term is positive, so final answer is negative and it is 0.01168. Again next is this term is positive and this term is negative. So answer is minus, so it is minus 0.0022. Again next term, two different signs, that's why answer is minus. So minus 0.00252. So if you calculate this, then the final answer is, here you cannot see this, here I had written it, but now it is not visible in this PDF. So I will show it here. Your answer is 2.7612. Now, how to check whether our answer is correct or not? Now, we have to calculate it at x equal to 46. Let us go back to our table. See, here x equal to 46 means here the value is next to 45. Now, what is our answer? Answer is 2.7612. So, it should lie between this two values. So if you observe here, it is decreasing values. So here first value is 2.8, then 2.4, and what we are getting, it is 2.7. So it lies between these two values, that is 2.8 and 2.4. So if you are getting such type of consequence, means this relation properly, that here all the values if you see, then these are decreasing values. So my next value 46 I am getting is 2.76 something, which is less than 2.87 and greater than 2.4. So my answer is correct. So in this way you can verify your answer in this example also. It is better way, if you substitute properly the values, you will get the answer correctly. Let us go to the next example. See, here is the next example. Construct the forward difference table from the following data and find value of y8. Now y8 means f of 8, that is x equal to 8. So here is the data. Now you can see this table. Now I will not explain this table again. So you know now how to calculate it. So I am again interested only in this first values, delta y0, delta square y0, delta cube y0, delta raised to 4 y0 and delta raised to 5 y0. Now sometimes it happens here in the fourth order difference both are same. So what is subtraction if next difference will be what? Delta raised to 4 y1 minus delta raised to 4 y0. So obviously it is 0, it may come. So that is only we have to require the formula up to delta raised to 4y, though we have n equals to 5 values. So let us substitute here. First we write the formula here. y0 equal to u into delta y0 plus u into u minus 1 upon 2 factorial. So up to 5 terms here I have given, but only up to 4 terms we need it. Then u equal to x. Now what is x? At y8 we want to find. So x equal to 8 here, h equals to 5. You can say here that 0, 5, 10. So the difference is of 5. N equals to 5 and x0 equal to 0 here. This is my first value. So x0 equal to 0. So x0 equal to 0, x equal to 8 and h equals to 5. So 8 upon 5 is 1 upon 6. So now here I have calculated directly this value. Now it is on you that how you are doing this value, whether to calculate it value of u and u minus 1, u minus 2 separately and then substitute it, or directly, or anyway. So that is all of on you that how you are going to calculate all these values, but you calculate it separately. This is my suggestion, because if you put it in the formula and try to calculate, then it will be very confusing, and it will be, I mean, sometimes we will get confused that which value we are calculating, where to subtract, where to add, and where to divide, where to multiply. That's my suggestion, that you always consider this value separately and calculate them separately, so that there will not be any mistake. So here I have calculated all the values. So u equal to 1.6, then second value is 0.48, and in this way. So here you have to take care of the signs, whether it is minus or plus, otherwise your final answer will be wrong. So now substitute all these values in this formula. Again, I am showing this formula here in the box. So as soon as you will get all the values of the forward differences. This is y0, this is delta y0, this is delta square y0, this is delta cube y0, this is delta raised to 4y0, and as it is 0, though it is 0, I have written this next term also, delta raised to 5y0, and these are values of the expressions related to the x. So if we calculate it separately, then in the final answer you have to substitute only that values and get the answer, which is very easy. So here this value is 11.76. Also you can see this whether our answer is correct or not. What we want to find? We want to find value at x equal to 8. That is, it lies between 5 and 10. And what are the related values of this y? The related value of corresponding value of y at x equal to 5 is 10, and at x equal to 10 is 13, and what value we are getting? It is 11 point something. So obviously it lies between 10 and 13, means we can say that our answer is correct. So actually this is not accurate value. In numerical analysis we never get accurate value, we always get the approximate value. So this is approximate value, as it lies between 10 and 13 here. 10 and 13, our answer is correct. So here we have seen two examples of this. This is another example I am giving you for the practice. You can construct the forward difference table and obtain the value. Now here your function is y equal to root x, and you have to find it, evaluate square root of 151. Means what? Your value of x is 151 here. Though it is given in the square root, it is a function notation, as your function is y equal to root x. So you can practice this example at home. The answer should lie between 12.247 and 12.329. If you will get the answer lies between these two values, then you can say that your answer is correct. In the next lecture, we will see, if possible, again 2-3 examples based on this Newton's interpolation formula and shift operator. Thank you very much.